with grid forming batteries. They've got a 250 megawatt hour grid forming battery that is in development now, and that's going to provide some synthetic inertia. So there's that option. And then we've got this project from...
Wait. You use the word synthetic inertia. Want to explain that for a second?
Yeah.
What is synthetic inertia?
Well, you're the electrical engineer, aren't you?
Well, I know what inertia is, and I know what synthetic is. You try to merge two things that don't go together. Inertia has to do with rotating mass, right? So it's not synthetic. What? It's
they're trying to mimic inertia.
Welcome back to the Uptime Wind Energy Podcast. I am your co-host, Alan Hall, and I'm here with the Sultan of Surfboarding, Dr. Rosemary Barnes, all the way from Australia. And this week we have a really news-packed show about a variety of different topics. Purchase power agreements in the United States are all messed up right now, and the prices are jumping to unheard of levels, quarter over quarter, year to year. The rates are rising. Doesn't look like it's going to be any stop to it. Amazon is buying more renewables. Thank goodness. Siemens Gamesa is still in trouble, and Chinese wind is going to be entering into Western cultures in the near future. In tech news, can wind turbines stabilize the grid? Rosemary's going to answer that question for us. And then Ontario government awards a $1.6 billion contract for train electrification. So welcome to modern technology, Ontario. And then Catapult in the UK is connected Bladebug with EchoBolt to make a Bladebug EchoBolt combination robot torque machine. And then a freeze-thaw battery, which is some new technology where we heat something up, we store energy in it, and then we freeze it. And it holds energy for a long time. I don't know why we didn't think of that before. So let's get started with power purchase agreements. And the prices in the United States rose an astounding 28.5% versus a year earlier, according to online renewables trading hub Level 10 Energy. So the first quarter renewable PPA prices rose 9.7% to $39.91 per megawatt hour compared to fourth quarter 2021. That's a pretty substantial jump, Rosemary. And individually, PPA prices for solar increased 6% versus 15.8% versus a year earlier. Sorry, let me explain that again. Individually, PPA prices for solar increased 6% quarter on quarter and 15.8% versus a year earlier, while those for wind went up 13.5% and 41.5% respectively. So the PPA prices for wind grew almost 50% year on year. That's crazy. Rosemary, what is making these large increases in PPA prices?
Yeah, and who's getting this increase? So, I mean, the way that the wind turbine manufacturers are talking, at least it doesn't sound like the money's flowing through to higher prices for them. So I guess it's the developers, but yeah.
There you go.
I think it's just driven by so many companies now have renewable energy targets, and the supply chain is a little bit constrained. You know, there are some choke points for, rolling out new wind and solar farms as fast as they could be,
right.
used. And so I think that's basically it. Companies have announced targets, and now they need to pay more to achieve them. Otherwise, they get the bad PR of having, made a target and then not actually met it. So yeah, I think that's where that's coming from. And I hope that it's temporary because...
you think it's temporary? I don't think it's temporary. I think it's long-term because the supply and demand curve are all whacked out.
I hope it's temporary, but if things don't change, it won't be temporary. It'll be permanent. But there are some pretty, I don't know, in my opinion, easy things that we could do to roll out renewables faster. I think that there's a lot of bureaucracy that doesn't need to be there. There's more transmission that needs to be built and more understanding of, how to, where to put new projects and how to integrate them faster into the existing grid. There's quite a lot of things like that we could do so that we could get the projects to come on board faster. Because I mean, all the developers I know have a long pipeline of projects, and like we've we've got all these projects, but we know that we're not going to get them all. Partly because of supply chain problems, but they're mostly citing grid connection in Australia is the real big problem. It's just taking ages to get things grid connected, and transmission is not being upgraded as fast as it needs to be. It's one of the big points of difference between the major parties in our upcoming federal election. So I'm really hoping to see some meaningful change for that in the next term. But let's see.
If the trend continues, and it looks like it's going to continue, level 10 analysts expect corporate demand for renewable energy to continue to expand, with the Security and Exchange Commission (SEC), and that's a U.S. bureaucracy, seeking to increase accountability around emissions of individual businesses, adding support. So what they're talking about is sort of twofold. One, there's social pressure for companies to buy these power agreements, and it looks good on your SEC filing. So every quarter, publicly traded companies have to file with the SEC, and they're talking about putting rules in that they have to show how much, basically how clean they are to society, and there's societal pressure and SEC pressure to force them to buy more PPAs, thereby raising the price. So if I am a large provider of renewable energy, I just sit there and wait, because people are going to be knocking down my door to pay me. And that's a great situation for operators, but it's a really bad situation for OEMs, wind turbine OEMs, because they're going to get squeezed. So I think the conditions are right for Siemens Gamesa, GE, Vestas to start entering into the power market. I think that's inevitable, that you got to have a sort of a vertical chain here and be on the receiving end of some of those funds. Otherwise, you're going to be left in the dust, because companies like Amazon continue to buy renewable energy. Amazon has a goal to make all of its operations powered by renewable. So that's 100% of its operations powered by renewable by 2025. So they were actually shooting for 2030. Now they moved it up 5 years. So 2025 is pretty soon. We're 2022, 2023, 2024. Boom. There you go. So yeah, we're pretty close. So the company Amazon announced that they have 37 new renewable energy projects around the world, increasing the capacity of its renewable energy portfolio by nearly 30%, from 12.2 gigawatts to 15.7 gigawatts. And that number doesn't make any sense, but okay, let's just take it for what it is. Bringing the total number of renewable energy projects to 310 across 19 countries. That's interesting. Now, some of these projects are in Australia, Rosemary. So they're not just doing it in the United States, they're doing it in the US, Spain, France, Australia, Canada, India, Japan, and the UAE. And it varies, of course, what part of the world they're in, if they're doing solar or if they're doing wind, and just, where they're at. But one of the largest plants is going to be a 500 megawatt solar farm in Texas, of all places. Boy, Texas has been in the news a lot lately on renewables. So if you have large companies like Amazon continuing to go after PPAs and actually do their own developments, there's a huge demand. Amazon's just one of 500 or 1,000 companies that are like them that can sort of do these large projects. Isn't there just a huge demand for renewables to happen? And shouldn't the wind turbine OEMs be making a fortune right now? What am I missing?
You're missing that you can't get the projects installed as fast as people want to install them. That's the issue. I don't think that developers have it so easy now either, because they've got rising prices, and they are constantly experiencing surprises in their development, because I will go back to the Australian grid connection thing. Some people are waiting months, years longer than after they thought that they had already gotten an approval. They're actually being delayed to be allowed to actually, flick the switch and and connect to the grid, and that is incredibly expensive if you've got everything sitting there ready to go and unable to make any money from it. So I think it's pain all around. And I do think that this is where, governments who want to do something for their climate, want to do something for their renewables industry, they need to smooth the way for the projects to get rolled out. We don't need push on demand anymore. You can see that the demand is there. What you need is to, get rid of some of those bottlenecks that are, just like artificially standing in the way of how fast we could really move with this energy transition.
So does it make sense for Amazon to buy a wind turbine OEM and do it all? Because it seems like they have the money to do that. If Elon Musk can pay $45 billion for Twitter, a stupid app, then Bezos can definitely buy, or whoever runs Amazon anymore, can definitely buy a solar production factory and could easily purchase a wind turbine OEM today. Couldn't they? It seems like that would be a drop in the bucket compared to their wealth.
But do they need to? Is that going to solve any problem for them? I mean, the problems are in the development planning phases, and also some of the raw materials, steel and stuff like that, even shipping. I'm not seeing what problem buying a wind turbine manufacturer would solve for Amazon.
I think it puts them in a huge marketplace. So we just talked about PPAs being in such demand that there's going to be even more demand as you get over the next 10 years, going 20 years, going to be huge demand for them. If that's the case, it's like with Amazon Web Services. And I don't like using analogies, but I'm going to use an analogy here. Amazon Web Services was something that started because they had a whole bunch of servers sitting out in the middle of nowhere because they needed it to run Amazon. And they realized, hey, we got all these extra servers. Why don't we just, let other people borrow it or rent it? Okay, there you go. Now you got a whole new industry. And it's very similar to Musk with the batteries and the solar cells. Somebody needs to get into wind, because there hasn't been any big billionaire type person, big name person in wind yet. It seems like that market is ripe because there's just such a depressed OEM pricing. For GE Renewables is not doing well, even though they have great technology. Siemens Gamesa is struggling, even though Siemens definitely has the power to pull them out of that. Vestas is probably obviously the most successful of all of the OEMs at the moment, but even then, I don't think they're worth $30 billion. Do you? I think they could go less than that. And if Bezos wants to make a real impact in terms of renewable energy, somebody's going to have to step up here and do it, because then you can control the whole chain from making steel, which is what, and Musk is somehow involved in making steel and batteries and a bunch of other stuff. It would be part of the vertical integration. Doesn't it seem like the logical conclusion of this? It's got to go somewhere. We can't sit where we are right now, I don't think.
Maybe. I'm prepared to watch and see. It doesn't sound obvious to me. But yeah, and I mean, there would be a lot more pieces of the puzzle to fit in for Amazon to, reach that full vertical integration. I think maybe they would move to development next. And I don't know. I don't see it personally, but I'm prepared to watch and wait and see what happens. It's an idea. And I mean, the wind turbine manufacturers are struggling at the moment, so maybe there's just going to be a screaming deal on a good manufacturer, because they've all got really good technology, but I think it's not unlikely that we'll see some bargain basement, valuations in the near future, and people that need to, maybe need to sell or go bankrupt. That might be their two choices. And then I could see any one of these, benevolent billionaires, whether it's Musk or Bezos or Australia's Mike Cannon-Brookes, or I don't know. I can't imagine Bill Gates. Maybe.
Warren Buffett is heavily invested in wind right now, right? So they own, Berkshire Hathaway owns Mid-American, I believe. So there's one huge player in the marketplace, and Amazon's obviously buying all the power. It just seems like a natural conclusion to this, because the pricing pressures are so enormous at the moment. Something has to change. And the CEO of Siemens Gamesa has been talking about material prices and raising of wind turbine prices. So Siemens Gamesa is going to raise its prices by high single digits to low double digits. So I think they're talking about 10% price range because the cost of steel and copper and all the other things in wind turbines is growing so fast. They can't keep up with it. So they're going to have to raise prices. And I think also, Rosemary, to your point, they also see that the the operators are selling these PPAs for crazy amounts, and the OEMs are not getting any of it. So in a large industrial base like this, back in the early 1900s, they would have colluded, totally would have colluded, and set the price floor so that all of them can make money. But in this new world we live in, they can't collude, and so they have to sort of look at one another and say, okay, we all have to raise prices, right? And the way they do that, if you watch, is they go to these conferences and they say the pricing pressure is overwhelming. We need to raise prices. And then they wait. And they wait for the next CEO to jump in and say, we need to raise prices. And so they come to a consensus out in the public, which is a different way of doing it, but it's still a consensus. And if everybody feels like they're going to raise prices, then there's less pressure, there's less pressure on them. So they can raise prices and know that their competitors are going to do the same thing. So I think there's some really interesting dynamics going on at the moment, because the big elephant in the room is China, right? And China is really lowered the price of the wind turbines. It's these crazy numbers. Chinese OEMs have lowered their costs roughly in half over the last year or so. And it seems to be a couple of market dynamics been playing into it. The Chinese government has lowered the price they're paying for energy. So they had power purchase agreements that were in the $80 to $100 per megawatt hour, and that got cut in half to $48 to roughly $55 per megawatt hour. So the Chinese producers had to lower their prices to accommodate that, and that drives down the Chinese market, which makes the Chinese OEMs look outside of China for marketplaces, which is what they're doing. And I think they're going to be banging on a number of doors. The question is, Rosemary, like we talked about in sort of the carbon limitations that the EU is talking about, does the EU, the United States, just basically tariff off Chinese wind turbines? Is that the next step? Is that just where it has to happen?
I'm not sure. It's been an ongoing story, this, because to start with, it was all about European manufacturers and especially Danish ones. And I know that the kind of, popular opinion in Europe, at least, was that the Chinese competitors weren't a problem because the European quality was so much higher, and, people would care about quality as much as they would care about price. And then I know that most of the European manufacturers and GE as well tried pretty hard to get into China, mainly failed, weren't able to, get a lot of that market because, the price is pretty hard to compete with. And I know with the, projects that I worked on, I would get information about what the, the target cost price was based on what some of the Chinese manufacturers were selling a similar product for. And it was like impossible to see how you could ever reach that just based on the raw materials, let alone, allowing anything for development or engineering or anything. And then now we're seeing the second phase of this, where it's not just about like Europeans trying to break into China and failing, but now we're seeing more and more of the Chinese manufacturers breaking into other markets. And I don't know if it's just a perception thing or if the quality really has gotten better, but it doesn't seem like there's not the perception of a big gap anymore between them.
Right.
And so I think that it is a really difficult place to be, but I don't think it's going to be the way it's going to play out. I don't think it'll be that, the Chinese manufacturers just, dominate and all of the European and American ones go out of business, because I think that right now people are very concerned about protecting their supply chains for things that they need. Countries are concerned about that. And if you look at like the US and Canada, have battery supply chain projects in place to make sure that they have a robust supply chain for everything that they need for batteries. And I mean, what's the point in a battery if you don't have any way to, charge it? So obviously you're going to need wind turbines, and solar panels are going to be part of that too. So I will be pretty surprised if these governments just sit back and allow this takeover. But I don't know how they're going to stop it, what form it will take, whether it will be tariffs or whether it will be some sort of favorable tax treatment of their own companies. I don't know. That's way outside my area, but I'll definitely be surprised if if all of the companies with a long history of making wind turbines, I'll be really surprised if they're all just allowed to fail based on the pure economics of it.
I guess the question is it going to be done quietly, sort of behind the scenes, or is it going to be something that the EU, the United States, crow about? And I think that's the decision that has to be made right now. I think it's going to go quiet. It's going to be done in legislation, sort of buried in a bunch of bureaucracy. But I think it's going to happen, and we're just going to read about it in the news at the bottom of the last paragraph in a New York Times article, like, hey, we put an embargo on Chinese wind turbines. That's how it'll go. And just because they're trying to keep some sort of relationship with China at the moment, and it makes sense to do that. But I agree with you. I just don't see any way the OEMs in Europe and the United States survive it without it. So we're going to take a quick break here, and Rosemary's going to explain to us how renewable energy can actually stabilize the electric grid. We'll be right back.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
All right, welcome back to the Uptime Podcast. We're going to be talking about how renewable energies can help stabilize the grid. And there's a project been going on in the United States with General Electric and the National Renewable Energy Laboratory. And they are operating a common class of wind turbine in a grid forming mode, which is when the generator can set the grid voltage and frequency, and the wind turbine can basically operate without power from the electric grid to synchronize it up. So there is a part of the electricity grid about consistency of power. The frequency must be within certain tolerances, and it can't vary. It can't vary in amplitude very much, because everything that's connected to it has problems when you start moving the frequency around and start moving the amplitude up and down. So the NREL and GE are showing that they can basically use a popular type of wind turbine to stabilize the power grid. Now, as we get into a more and more renewable energy situation in the United States and Australia and Europe, a lot of the coal-fired generation and the gas-fired generation and in some places nuclear are going to start coming offline. So we don't have those big rotating masses to synchronize the grid. So, Rosemary, are these new efforts to synchronize the grid with wind turbines and other renewables going to be the future, or are we always going to have some big gas-fired, electrically turned, synchronous mass to keep the grid frequency and amplitude going?
I think we're definitely going to move away from the physical inertia that we've had with thermal generators. They're just so big and heavy that when they're turning, even if, like demand suddenly drops off, it can't slow down that fast. And so, it automatically, it has, like actual inertia in the, in the sense that you learn it in your high school physics class. It's got that inertia in the system, can't be slowed down. And then you've got, so that's fossil fuel using stuff or nuclear, big, you use some sort of heat to generate steam and turn a huge, massive turbine around. Then you can kind of copy that, but without the fossil fuel usage, with a synchronous condenser, which is also a big, massive rotating thing, but you can spin that up using electricity from, whatever source. It can be clean electricity. So that's clean, but it's still kind of, like old technology in a sense. I was just copying the old technology. And then we've got the new ones, the new technologies where you're actually trying to do away with any kind of spinning mass, and you make it, sometimes they call it like artificial inertia or synthetic inertia or electronic inertia, where you're trying to, have a really fast response that will have the same effect as the, inertia of a physical system.
Mm-hmm.
And so I've seen in South Australia, it's a gigawatt scale grid, and it's actually it's a really interesting one to watch because they have the most variable renewable penetration of any grid of that size in the world. So they don't have any hydro, so all of their renewables is wind and solar. So it's very variable.
Wow.
And currently, they often have times where they have more than enough wind and solar for their whole grid, and they're connected to other parts of Australia, so they can export it. But they always need at least 2 thermal generators running to provide this inertia. And the reason it's 2 is in case one of them breaks. So you've still got 1. Yeah. And so they will soon be doing some trials to move away from that. One part of it is with these synchronous condensers. But that's kind of easy because you already know exactly what's going to happen when you have that in place, because they behave just like a thermal generator. But another thing is with grid forming batteries. They've got a 250 megawatt hour grid forming battery that is in development now, and that's going to provide some synthetic inertia. So there's that option, and then we've got this project from.
Wait. You use the word synthetic inertia. Want to explain that for a second?
Yeah.
What is synthetic inertia?
Well, you're the electrical engineer, aren't you?
Well, I know what inertia is, and I know what synthetic is. You try to merge 2 things that don't go together. Inertia has to do with rotating mass, right? So it's not synthetic. What? It's
they're trying to mimic inertia. So there is the physical inertia, and it has the effect of stabilizing the grid.
Yeah.
But you can also program a battery so that it also rushes in at within the split second to correct the frequency and the voltage in the grid. That's my mechanical engineer's understanding of how synthetic inertia works. Don't ask me any more questions, any more depth on that one.
Well, okay, so let's talk about that for a second. So we have a rotating mass, which is the way we would do it today. So we have this big massive thing spinning around, and if there is some big disconnect from the grid, which there can be occasionally, the inertia of this, basically a generator at that point, just dumps massive loads of energy to stabilize the grid. It loses some momentum by doing it, but it's essentially it can fill in the gaps instantaneously, or pretty close to instantaneously. Can a battery solution do the same thing? Can it do that massive dump of energy to stabilize that grid? Because the consequences of an unstable grid are not that your iPhone stops charging. You start losing like really big industrial things, motors, 3-phase motors, and that drive your economy get wobbly and don't like it and start doing damage to big industrial sites. So it's really critical. So can that system really support a whole big, large grid, a battery system?
In theory, yes. And we already see batteries. I don't know how it works in the US, but in Australia, all of our grid batteries are all providing ancillary services to the grid. So it's mostly, frequency support. On a smaller scale, they're not the only thing there. They're not forming the grid. They're, just, maintaining it. And yeah, in reality, I guess we don't know the answer to the question of whether that's possible on the whole grid scale yet, because everyone's only in trials. No one is just, doing it all the time. But I don't get the impression that anyone thinks that we're going to fail to make this work in the next few years.
I'll tell you how it fails.
And then what I thought was, how does it fail?
You know how it fails? So here's the thing about batteries, right? Batteries are in a mode to self-protect. And if there is and most battery systems are made identical to one another, right? And we're seeing the same thing happen in aviation, by the way. This is why I know about it. So when batteries go into self-protect mode, they go off regardless. So they just say, I don't want to have a fire, and I'm going to turn myself off. If you have that happen in multiple places in a sort of a synchronous grid, you're going to have a big problem where a large rotating mass does not care. And I think that maybe the difference here is are we looking at what the failure modes are? And when we thought about the common mode failures, it may be in a system like that, where you have the same repetitive battery system in different parts of the grid, that they may act simultaneously to disconnect themselves, or to do something synchronously that it shouldn't do. Does that make sense? Why you wouldn't want that?
Yeah, and I mean, I'm sure that that's the kind of issues that they're looking into with the trials, and to see how much redundancy you need and how to make sure that you
There
don't
you
get
go.
the same failure mode being copied in multiple things. Yeah, I mean, I don't think
There you go.
anyone's suggesting you just switch off all the thermal generators one day and switch on your synthetic inertia instead, without doing it gradually. And at first they'll do it incrementally, and with some physical inertia as a backup
Mm-hmm.
in place. Yeah. But what I haven't seen before, this project that you've raised with GE and NREL and the wind turbines, I've never seen a wind turbine used in this way. And I think it's interesting. When I first learned about inertia, I thought it was really interesting that you always talk about, spinning generators versus renewables. And I mean, of course, to me, a wind turbine is a spinning generator. It spins, right? But it's not providing inertia, even though you can't physically stop a wind turbine in a split second any more than you can stop any other large mass from turning really, really fast. It isn't providing that grid inertia, and I don't want to get the explanation wrong, because you're the electrical engineer, but my understanding of that is because they're variable speed generators, right? So they change speed to match, to keep them efficient in multiple wind speeds, and so you can't just use them like a traditional to provide traditional inertia. So that's why this project I believe is also or they're calling it virtual synchronous generator.
It's all virtual.
So I assume that's
they're faking it out,
electronically imitating the stabilizing feature of conventional generators.
Right. We're living in the matrix. Yes, that's exactly what we'd be doing. And I think that's the part that we don't know, right? And engineers are definitely, the grid is not something to play around with. Your whole economy is based on the grid, so you can't have it go offline like we have had it done. It has happened several times in like New York City, where the grid has gone off and you have to go figure out why. Like, oops, we made a mistake. You just don't want to do that if you can avoid it. And if we move to something that's renewable, that's great, but we ought to make the grid more reliable, more redundant. And that's probably where GE and NREL are going, because we're going to more electrification. And there's a big effort up in Ontario to make their GO Transit train system electrified. And so the Ontario government is spending $1.6 billion as a first phase of electrifying their train lines, and they're going to start electrifying it in 2023, and are planning 11 years to do this, which seems like forever, Rosemary. This train line's not that big, so 11 years is a long time. So they're going to run an all-new electric train fleet. And Rosemary, you have relatives up in Canada. How big of a deal is this to electrify these trains?
Well, I think it's a pretty big deal, because they're currently diesel trains, so they have to just get rid of them. It would be easier in some other places are using like diesel electric trains, where you would be able to just convert them over to run on to run electrically, or to be all electric. So that's a big deal. I thought it was interesting because, it's a big government project to put some infrastructure in, and I haven't seen a lot of that in the energy transition, where governments really, spend a lot of money up front to make the system more efficient in the long term. I keep on coming back over and over again to transmission, but that would be an example of where, if we would get that right, we could have really cheap electricity after that, because, if everything was in place and set up correctly. Other examples are, you could do the same thing instead of electrifying, or as well as electrifying trains, you can also electrify the roads, so that you can have, electric trucks without huge batteries. But it's a huge upfront cost. And even though when you look at the economics of it, over 10, 20, 30 years, it's cheaper. It's a cheaper way to do things. They don't seem to happen anymore. They did back in the, 30s and 40s. Governments were doing these big infrastructure projects. And I mean, that's how I think basically all hydroelectric dams got built, because they don't pay themselves back in 5 years. Like, like a private company would want them to. If they build it, sometimes they need 50 years or more to pay back the investment. But after that, it's something that you have. So I guess Canada would be the place for it to happen. And then other than that, like Scandinavia, those places where they do seem to trust the government to spend their money for the long term. But I would not see, we can't even get trains in the first place in Australia, not really, because that's too much, public money to spend up front, and everyone's wondering what's the business case, and it better have a 5-year payback period. And I feel like it's a shame that we're so fixated on these short payback periods. To me, that's what government should be for the stuff that's too long term for private companies to make money from, but would benefit people in the long run.
Well, so Bombardier, which is not Bombardier anymore, up in Canada, was building battery-powered trains. I'm sure it was just outside of Montreal. Now that division had been sold off to Alstom, I think. So there are battery-powered trains right in Canada that are being manufactured, and I think they were making those trains for Germany. So they had basically a clean battery train transit system all ready to go. I'm surprised that Ontario, if that system is still working, that Ontario didn't grab hold of that, because that would solve a lot of problems. Instead of having to electrify all the track, you would have these battery-powered cars. I assume you'd be able to charge them up fairly quickly and thereby eliminate a lot of the infrastructure problems. So there's some cool technology up in Canada, and it seems like they're headed in the right direction. And you're right, Rosemary. These large infrastructure projects have come in times of economic downturn for the most part. It seems like we're headed to one now. So maybe this is a way of investing in the economy to kickstart the economy again, and maybe get some electrification out of it. And that would be good. So we're going to take a short break right here, and we'll be right back talking about tension, torque, and robots right after this.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by Weatherguard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Welcome back to the Uptime Podcast. Two techie things to finish off our show. GE and the offshore renewable energy ORE catapult over in the UK have demonstrated how a 6-legged robot called Bladebug can inspect wind turbine bolts autonomously, eliminating the need for technicians to loosen and retighten thousands of bolts per turbine as part of routine maintenance. So this is the culmination of two ORE catapult companies that have come together, because I think they're probably located in the same building. Bladebug, which if you've watched LinkedIn or YouTube, you see this little 6-legged creature crawling up and down wind turbine blades lately. It's a really cool project, and we've had Chris Cheslek, the founder of Bladebug, on the podcast, and EchoBolt. And EchoBolt is a technology which uses ultrasound technology. And Rosemary, this is going to be in your world, not in mine, of checking bolt tension, checking bolt tension using ultrasound. And I don't have any idea how that works, but it sounds like they've combined the robot Bladebug with this EchoBolt technology. They can autonomously let this robot run around inside of a wind turbine and check to make sure all the bolts are tight. So the robot successfully crawled in the interior of ORE Catapult 7-megawatt lead mouth demonstrating turbine in Fife, and it identified any of the bolts that didn't have the proper tension. So this sounds really cool. It's actually applying two things that if you think about offshore wind, how are you going to check all the bolts all the time? Are you going to send a person on there onto each of these little offshore rigs to go tighten the bolts and check them all? Or are you going to have a robot that just lives there and checks the bolts every once in a while? Doesn't this sound like cool technology, Rosemary?
Yeah, I think so. Sometimes we talk about wind turbine failures on this show, and we speculate. We never know the root cause of the failure, because obviously the companies don't share that information. But in my mind, I'm always assuming that it's some failure to check the tension of bolts in the annual maintenance, or and after the commissioning period they usually check them again. So this would be a really good way to hopefully avoid some of those problems of missed problems, I guess. catch them. I don't know how it works with the ultrasound testing. Are they just checking? I guess you could see, which parts are binding and which parts aren't. Maybe there's some like contact conditions that they're looking for. I can't really see how that would work otherwise. It would be interesting to look into.
I'm going to describe this with my hands. So unless you're watching on YouTube, you're not going to see this. But as you tighten a bolt, you stretch it, right? And I'm assuming that as you stretch it, that's its tensioning. There you go. And this is an electrical person speaking, so stop me when I go off the rails here. But as you tighten that nut down, the bolt gets a little bit longer and gets stretched, right? So I'm assuming that the EchoBolt system actually measures the length of the bolt once it's stretched to see if it changes. That's what I'm assuming. I know there's more math and physics beyond it, but that seems like the basic fundamentals, that if you knew what the bolt length was ultrasound-wise, you could then check it 6 months later to make it sure it's the same length. Does that make sense?
It maybe. How much do they actually stretch compared to the how accurate the measurement is? Maybe that's how it is. I think I've just realized that neither of us have any clue how this thing works.
Oh, I think I'm pretty close, actually. I think I'm pretty close. Now, we've asked EchoBolt to be.
Know.
I don't know. We've tried to have EchoBolt on the podcast multiple times, but they've always been too busy. So now that they've connected with Bladebug, now they need to come on the podcast and explain how this magic works, because this technology is needed in industry, and we just don't understand the physics behind it. Yeah. And so we just need to know, right?
But
so
you're absolutely right that you're absolutely right that for offshore, it will make a huge difference, because everything is a pain offshore, and the less people that you have to send out there to physically, are they actually loosening and tightening bolts because you can't just put a torque wrench onto a bolt and measure to the torque like that. You do have to actually be tightening it to measure the torque, so it's not such a straightforward process. I know if you go inside a wind turbine, the main first warning sign is always someone will get a paint pen and draw a line on the nut and onto the side of the whatever it's attached to, and just make sure that it hasn't rotated. And that's the high tech way to do a quick visual check that your bolts aren't losing tension. But this is obviously going to go a little bit better than a hand drawn paint line on there. So really cool.
Yeah. Well, I guess they could. I guess the robot could check to make sure the paint lines do line up. It's just the first check that it does is say, okay, the paint line is still there. I don't need to check this one. I can go check the other ones. Even if it just did that, that'd be a huge improvement than putting a human out there in the ocean to go do that on thousands of turbines. Mm. So that's pretty interesting technology. And if EchoBolt is listening, they need to come on to the podcast. All right. So in our next story, there's this new sort of development battery called a freeze-thaw battery, which freezes its energy for later use. It's basically a step towards batteries that can have really long-term storage. So you could actually put energy in this battery in the springtime, and then when it gets cold outside, you can release this battery for heating or whatever. So they're talking the Northwest National Laboratory has published some description of this, and right now it's only the size of a hockey puck. And Rosemary, do you have hockey in Australia? You know what a hockey puck is?
Not really. Okay. I know what a hockey puck is, but not because we play hockey a lot in Australia.
It's too warm.
I've been in Canada. I've seen a Canadians game. It's fun.
All right. Well, there you go. So it's about 3-4 inch diameter. So the concept is it's a battery that sort of works on a molten salt. So they heat it up to 180 degrees Celsius, allowing the ions to flow in the liquid electrolyte. And they put a bunch of energy in it. When it's hot, then they cool it to room temperature, and all that energy is locked into the battery. So it's like a suspended animation sort of thing. And then when they need to release the energy, they heat it back up again, and then the energy flows out of it. So it's a way of having really a long-term battery storage. And I guess the question is, first, do we need something like that stores energy for months at a time on the grid? And if so, is this a possible solution to that?
I think it's a possible solution. I think that the reporting on this falls into a lot of traps that you see for new technologies, that are trying to generate hype, in that I think it misrepresents what the real problems are and misrepresents what other technologies can do. I mean, we already have technologies that can hold energy seasonally if you want. I mean, there's nothing stopping you if you've got a dam with pumped hydro capability. Nothing stopping you from pumping the water uphill in July and then leaving it there until January. You can do that if you want. You're not really going to lose anything much. Even a lithium-ion battery, usually a lithium-ion battery is only 1 or 4 hour duration, but it's not because it's going to lose all its charge over 4 hours. It's because it's not economic to just charge a battery, buy a really expensive battery and then you do, infrequent charge cycles. So if you've bought a battery, you want to be getting as many charge cycles as you can. And it's usually, once a day is kind of the minimum that you're going to want to be able to get your money back, or, make a profit. And then for seasonal storage, there are you can already do thermal storage, just much lower tech with just heating water up and leaving it in an insulated pond. People already have been doing that for a long time in Scandinavia and in Canada, and you can get 90% efficiency just from that. If you just want the low grade heat for, heating up buildings, then that is a much cheaper way to do it than this technology. So I think, it's cool. It's a problem we do need to solve, but we already do have solutions, and it's not the technology that's a challenge with seasonal storage. It's the economics. How do you make your money if you're only generating, every 6 months or so? That's really, really challenging. And that's why we don't see a lot of seasonal storage currently, because it's a lot cheaper to, continue to use fossil fuels, which can also be stored seasonally. So I think it's interesting. I don't think it stands out as a game-changing technology because there's lots of options, and so I mean, interesting to see how it develops. But it seems like at the size of a hockey puck, it's not imminent that we're going to be seeing this roll out next year or anything like that. So something to keep an eye out over the next 10 years or so, I'd say.
Let's try a bunch of different things and see what sticks. There's just saying that the battery's theoretical energy density is 260 watt hours per kilogram, which is higher than lead acid and flow batteries. So, I mean, there is something to say for that. The question is,
is it relevant though?
Is it relevant? Right.
To seasonal storage?
That's the question?
You're not going to be driving around, seasonal storage in a car or an airplane or something like.
That would not be a good use of the storage technology. No, absolutely not. So we're going to keep an eye on it, and there's a lot of new technology coming out in the battery world because it's going to be a battery future for sure. So that's our episode for this week. If you have time and you like renewable energy, you need to go check out Rosemary's Engineering with Rosie YouTube channel, which is approaching 1 million subscribers at this point. If you like watching us on YouTube, the Uptime Podcast on YouTube, you could also listen to us on Apple and Spotify.
Also approaching 1 million subscribers.
Well, aren't we all approaching 1 million at some point, right? But check us out on YouTube.
The number's getting higher, and that's the main thing.
That's what it needs to do. That's all we need to do. Trend up. So check us out on YouTube. Check out Rosie's channel on YouTube, and also listen to us on all your favorite podcast platforms. So we'll see you next week on the Uptime Wind Energy Podcast.